This next little bit here says when theta represents an angle, then any angle coterminal with theta is represented by this expression. And again, here's your expression in general term. So if you had whatever theta is, and again, usually you're picking your angle that's in standard, or you're picking your principal, both would work here. You're always going to go plus 2 pi n, and again, of course, 2 pi is, if you want to do this in terms of degrees, 2 pi is the same thing as saying 360. So this holds up for radian, but I can also rewrite this in terms of degrees. From lesson 1, it'd be theta plus 360 degrees n, and again, you'd have that condition of nei. N is an element of an integer on it if you're working in terms of degrees. Okay. So principal angle, again, so this is from lesson 1, but this time we're talking in terms of radian. So this is principal angle is the smallest positive angle between 0 and 2 pi. Okay, so let's determine the principal angle here. So if I'm starting off with a negative answer, I want to find the first positive answer possible, so I'm going to go negative 2 pi divided by 3, and I'm going to add on plus 2 pi. And again, if I run this on my calculator, I should get 4 pi over 3, and that's going to be my principal angle, and it's going to be coterminal to negative 2 pi over 3. Here again, I have a negative angle, so I'm going to add on 2 pi. So we're going to start off with our negative 5 pi 12, add on our extra 2 pi there. We're trying to find a positive answer, of course. This is now 19 pi over 12. Over here, this here I know is not a negative number, so what I want to do is I can probably either one, if you're not sure if this is between 0 and 2 pi, you should probably convert it to 360 to degrees and then see if you're between 0 and 360. But here I know that I am above, so I'm going to subtract off 2 pi in this case here. So if I subtract off 2 pi on this one, I'd have 2 pi over 3 left over. And how do I know if I'm above 2 pi in this case here, and how did I know to subtract? Well, if this my base is 3 here, 2 pi is the same thing as saying 6 pi over 3, because 6 divided by 3 is also 2. So I know that if I had anything bigger than 6, I'm going to subtract because I'm not in my range between 0 and 2 pi. So anything bigger than 6 over 3, I'd subtract. If it was, you could have had something like 12 pi over 6, because 12 over 6 is also 2. And over here, if you had anything, something like a bigger than technically 24 pi over 12, right? So you have your options here. You can convert 2 pi into 6 pi over 3 or 12 pi over 6 or whatever you really need to get it equal to 2. So 6 divided by 3 is 2, 12 divided by 6 is also 2. Over here, so we're going to talk about arc length. So this is kind of a new idea. Basically, arc length is just measurement. Okay, so arc length is just a measurement. So what are we doing? So arc length A, that is subtended by an angle theta in radians in a circle with a radius r. So subtended means if I had again my initial, my terminal arm, here's my arc length. I'm going to draw it off here in green, so it's going to attach these two, and it is curved, by the way. Subtended is going to be the opposite of the angle, so that's what we're doing. So that's what we're drawing. So theta is going to be right in here. Arc length A will be right here, and these two lines here, because it's the same line, they're considered my radius. It's r and r. Okay. So that's my picture basically. So again, here you're gonna have an equation A equals r theta, and again the trick here is it has to be in radian. So in example, and it says note angle theta must be in radian. So here in example 7 we have a circle with a radius of 6.5 centimeters. Calculate the length of the arc of this circle subtended by each angle if the angle is 2.3 radians. So we're just trying to find A, the arc length. So I'm going to jot down my equation. A equals r theta. Do I know my radius? Yes, my radius is 6.5, so let's sub that in right away. So we have bracket 6.5. And do we know our theta in terms of radian? Yes, we do. We have 2.3 radians. So I'm going to write 2.3 rads. Multiplying these two together, 6.5 times 2.3, we get 14.95. And my units now is going to be in terms of my radius, so my units here will be centimeters because it is a length. Okay, arc is a length. Over here, 75 degrees, the first thing I'm going to do is convert it into radians. So I'm going to take 75 degrees, multiply it by pi over 180. And again, I want to keep this as exact values as possible, so I'm going to go 75 divided by 180, math frac that to get it into reduced fraction, 5 over 12. So I have 5 over 12, and my pi is going to be right there beside 5. So once I have that, I'm going to go right into my equation. A equals r theta. Again, my radius was that 6.5 centimeters, and my radius now is 5 pi over 12. Or sorry, my angle theta in radians is 5 pi over 12. I'm going to multiply these two together, and what you want to do is, yeah, type it in on your calculator. So if you had 6.5, and then you have your 5 pi over 12, oops, 5 pi over 12, and there you go, you get 5.81, basically 5.81 centimeters. There you go, that's the second one. In example 8, we have a circle has a radius of 6 if a central angle of the circle subtends an arc that's 10 centimeters long, then the measure of the angle is. And so again, draw yourself a picture. It's a bit easier if you can draw yourself a picture. So if I have a radius of 6, and again, that's going to be 6 right around there. And if I connect these two here from here, oop, and that's not quite working. Basically, I'm going to draw it in this time. I'm going to connect these tip to that tip there. That's my arc length, and it says my arc length is 10 centimeters long, so I'm going to jot down 10 centimeters right here. My radius was 6 centimeters. So ultimately, I'm looking for this angle right in here. That angle is going to be in terms of radian, and of course, this question was slightly a trick question. It says, measure the angle correct to the nearest tenth of a degree, so it does want us to convert, once you have your radians, to convert that into degrees. So let's go. So let's jot down our equation. A equals r theta. Let's fill in our equation. A is now 10 equals r, which is 6, and theta, which is what we're trying to find. So I'm going to divide off the 6 on both sides. So theta is equal to 10 divided by 6. And this here, let's convert this into a decimal. 10 over 6 is 1.67 radians, so this is 1.67 rad. And if I want to convert this into degrees, I'm going to multiply by 180 over pi. And so this is going to get me my answer. Again, use that full decimal there on your calculator. So I'm going to go multiply by 180 divided by pi. And we get 95.49, which is basically 95.5 degrees. So again, this is a bit of a trick question because normally we would have stopped right here, 1.67 radians, but this one said to correct to the nearest tenth of a degree, 95.5. And again, this is a trick question because we usually measure degrees or angle to the nearest whole. Okay. In example 9 here, we have 2 points A and B are on Earth's equator, and point C is at the center, so center is right there. The measure of angle ACB is 74, and that's shown in the picture. If the circumference of the Earth's equator is approximately 40,070 kilometers, then determine the shortest arc length, so between A and B, from A and B corrected to the nearest kilometers. So, first things first, we need to figure out if we know the circumference, we're going to try to figure out our radius. And this is going back to your junior high days. So let's jot down our equation. So circumference is equal to 2 pi r, and r is what we want to find there. So our radius is going to be our circumference divided by 2 pi. And why did I need radius? Well, in my arc length equation, a equals r theta, the radius here is going to be the same radius over here. So let's solve this. So our circumference that we had initially was 40,070 kilometers, and we're going to divide that off by 2 pi. And in this case here, I'm going to try my best to keep this as an exact value. So I'm going to go 40,070 divided by 2. And notice that I'm not using pi there with my division, I'm just dividing by 2. So I'm left with 20,035. 20,035. This is all going to be divided by pi, and that I'm going to leave as exact values. That's easier to write over here than a big long decimal answer. So over here we want to find the arc length between A and B. So of course A is going to be equal to our radius of 20,035 pi. And we don't have theta in this case, we have a degree of 74, so I'm going to convert that 74 into radian by going 74 multiplied by pi over 180 in here. And so here we're just going to type all this into our calculator. Try your best typing this in, and here we go. We have our 2035 over pi multiplied by that 74 times pi over 180. Answer 8236.6 kilometers. So our answer is 8236.61 kilometers. And again, in the question it asks you to the nearest kilometer, so here we got to round up. So we're at 8237 kilometers for that little distance between A to B. And the last question for today: in 1 minute, the second hand of a clock completes one revolution around the clock face. In 1.8 minutes, the second hand of a clock completes an angle of how many radians? So, what do we know? It says in 1 minute, the second hand completes one revolution around the face of a clock. So that's the same thing as saying 1 minute is equal to, I can either say 2 pi or 360 because that's a full rotation. So I'm going to go with 2 pi because we're working in radians today. We're looking for 1.8 minute. So we're asking you how many radians is that? So basically this question here is cross multiply and divide. So that's exactly what I'm going to do. I'm going to go 2 multiplied by 1.8 divided by 1. Of course, it's still 3.6. So here I have 3.6 pi. And there we go. And that's our answer in terms of radian. If you wanted this in terms of a decimal, all you're going to do is 3.6 pi. So you're at 11.3 there. Okay. So, but here I am going to always try to leave my answer as exact values. Alright, so that's the end of our lesson. If you have any questions, please feel free to ask.